Hello everyone, in this video we're going to go over part 3 of the problems. First and anything, we're going to go for this equation of the circle. And so normally we don't have anything in company of the x squared or the y squared when we're doing the equation of the circle. So over here we have to get rid of the 2 that is in front of that. And so to do that, we're going to factor out or we're going to divide the equation by 2. We can divide the whole equation by 2. And so if we do that, we're going to get x squared minus 2x plus y squared plus 4y equals 3. Now at this point, we have the equation how it's meant to be for completing the squares. And we're going to set that up as x squared minus 2x, and then if we divide by 2, we get 1. So 1 squared is what we're going to add. And on this side, we divide 4 by 2, and so we're going to add 4. So this is y squared plus 4y plus 2 squared. And then it's equals to 3 plus 1 plus 4. So that is, this part is going to be factored as x minus 1 squared plus y plus 2 squared equals to 710. Wait a minute, 8, not 10. Now this is the full equation of the circle, and this is telling me that the center is at the point 1 dot minus 2. And now the radius should be the square root of this, which is the square root of 8. Now same thing is going to happen for b. We have 4's in front of the x squared and y squared. So if we divide everything by 4, we get x squared plus 2x plus y squared minus 3y equals 7 over 4. Okay? So now, same thing as before. We can add 2 divided by 2, 1 squared, 1 squared, plus, here is going to be 3 halves squared. And that's going to be equals to 7 over 4 plus 1 squared plus 3 halves squared. And here, then that is x plus 1 squared plus y minus 3 halves squared equals to, and then this will be 7 over 4 plus 4 over 4 plus 9 over 4. So in total, this is going to be 1620 over 4. So this is 5. So this means that the center of the circle is minus 1, 3 halves, and that the radius is going to be a square root of 5. Now let's move on to the next problem. We have the following diagram. This is the diagram where we have a boat that's being pulled by a cable, and so we have different instances. In the instance A1, we have that is a distance A1 of the port, and the length of the cable that is pulling it is a D1 of length. We have that this measure over here is 10, which is the height where we meet from the boat directly to this. So we're having a couple of right triangles. So we have a right triangle here with A1, D1. So we can see D1 squared is going to be equals to 10 squared plus A1 squared. And similar, D2 squared is going to be 10 squared plus A2 squared. All right, now we're going to suppose that the cable is originally 30 feet long. So we want to know with that notion how far from the pier is the boat. So for that, we're gonna assume, okay, so if this is 30 feet long, then this is going to be 30 square is equals to well, certain amount a square, which is going to be the distance, right? And 10 square, which is still going to be this height. So this will be what we want to obtain. So a is the square root of 30 square minus 10 square. That'll be how we obtain this particular value. Now C says, suppose that the cable is originally 30 feet long and the cable's real 3 feet per second. We want to find the average speed of the boat during the first 2 seconds. So we want to have t1 equals 0, and we want to check with t2 equals 2. And so d1 is going to be the original, which is 30 feet. And so also having that into account, then I can calculate what the A1 is. Right, so the A1 is going to be at t equals 0. And also we're going to have here d2, which is going to be the original 30 minus a reduction of 3 feet per second, so 3 feet per 2 seconds. And so that's going to give me 30 minus 6, so it's going to be 24. Okay. And so this is what we have, that it was originally from the pier. That was what we're going to use here in A1. This is, let me calculate that. So this is 900 minus 100, right? So it's the square root of 800, right? And so that'll be 28. Right, let's say this is 28. Now we can find A2 by doing the same thing that we did with this one. So it will be the square root of this 24 square minus 10 square. And so 24 square is 576 minus 100. So this is square root of 476. And that is going to be 21.8. Okay, so now to finally do our calculation, the average speed is A2 minus A1 over T2 minus T1. So we do 21.8 minus 28 over 2 minus 0. And so that is going to be minus 3.1. And so this will be feet per second. That'll be the rate of change of movement here for the boat. Now, problem number 9. For problem number 9, we have that a rectangle with a base x and a height y is inscribed in a right triangle. Okay, that has legs 15 and 25 inches. So, of course, we want to write an equation that expresses y in terms of x. So we want to somehow relate these quantities. The easiest way to do that is by doing a similarity of triangles. I can find the similarities between this big triangle and this small triangle here. Notice that this quantity here is 15 minus x, since everything measures 15 and this part measures x. So I can relate 15 minus x is to 15 as 25, sorry, as 15 minus x is to 15, so this small side is to this, as y is to 25. So with that, then I can say 25 is 15 minus x over 15. That is y. So this is the equation that relates that in terms of y. We can simplify by 5 here. And so this is going to be 5 over 3, 15 minus x. Now, if we want to write an equation for the area of the rectangle, x times y, the area is x times y, and then I can replace the value of y. So we get this particular area function. And now with this, we can find the dimensions of the rectangle with the greatest area, since now the area is a function of x and is and this is going to be a quadratic function. So you can go with your calculator or your Desmos and find out where this is going to have the maximum point. So let's actually do that. Let's do here Desmos calculator to find that point. And so we're going to find a of x equals x times 5 divided by 3, and then 15 minus x. So now we have this one in there. Let's see where the points are getting their maximum. So right here, and this point is going to be 7.51, 93.75. So 7.5 will be the value of x. 7.5. If I plug that to find y, then I just gotta plug it into this equation here, and I'm gonna get that that's 12.5 inches. And of course, the area that is x times y will be 93.75. Okay. So that will be the way to optimize in this particular problem. Now for the last 3 problems, we have different things that are related to area and volume. So for the first one, we want to calculate what will be what it takes for passengers in a carousel to complete 1 revolution. So a carousel is a circumference, and we are going through the circumference in 1.25 feet per minute. That's what we get. Well, that's what we cover in the movement. The diameter of the whole carousel is 40 feet. Okay, so that means that the radius is going to be 20. So the length of the circumference, if you remember, is 2 pi r. So this means that the length, or the circumference in general, is going to be 2 pi by 20. So it's going to be 40 pi, which I compute this in the calculator is 1.26 in terms of feet. Now, if I want to check how much it will take me to complete one full revolutions of this, that I'll have to divide 1.2566 feet by 1.25 feet per minute, since this is how fast I'm going. If I put this in the calculator, then this is going to be 100.5 minutes. Okay. All right, so that is problem 10. Now for problem 11, we have a ladder surface, the ladder surface area of a cylinder. So you got to remember that for a cylinder, we are taking a sheet and then we fold it around to get this. Okay, so this is 2 pi r. If my radius here is going to be 4 inches, it means that the length here is going to be 2 pi by 4. So 8 pi. Okay. And this height here is given by 10 inches. Right? So the area of the surface area, which is this, is just going to be a rectangle, which is 10 times 8 pi. So that's going to be 85 inches square. And that will be the entire surface area of this. We don't have any on terms of the covers. So if we have covers, we have to do pi r squared, but in this case we don't have any covers. They're not talking about any covers. So this is the simplest scenario that we can have for surface area. Now, number 12 is we want to find the volume of a frustum. Again, remember the volume of the frustum is the volume of this figure like this. And it has a volume pi over 3 by the height. And then it has the two radius and ball, where this is the small radius and this is the big radius. Okay, and here we have the two radius, 2 and 3 inches, and we have a height of 6. So we don't have to do much but to plug in the different values. Once that we plug that, we can put this in the calculator, and this is going to give me 38 pi. This is 9 plus 6 plus 4 times 6 divided by 3. Okay, so 38 pi, and because this is in inches, will be inches square. All right. So that concludes part 3 of the problems.